Hi, everyone. Thank you for attending today's webinar, introducing the SolarEdge 330 kilowatt inverter solution for large-scale ground mount projects. I'm Kelly Pickerel, editor of Solar Power World, and before we get started, I wanted to go over a few housekeeping items. You can view the slides for today's presentation in the resource window on your screen, and you could submit questions related to today's webinar in the Q&A window. If we do not get to your question, our presenters may reach out to you afterwards. And finally, if you are watching this webinar on demand, you can still use all of these features, including sending questions to our presenters. So let's get started with today's webinar on SolarEdge's 330 kilowatt inverter. I'd like to thank SolarEdge for sponsoring this presentation. So today we will hear from Kleber Ficini, Director of Product Management, Commercial and Utility, and Varsha Murthy, Senior Product Marketing Manager. They are both with SolarEdge, and we're going to learn all about the inverter for large ground mount projects. So now I will turn things over to Varsha to get us started.
All right. Thank you so much, Kelly. And thank you to Solar Power World for hosting us. Welcome, everyone. We are super thrilled to introduce our new groundbreaking SolarEdge optimized solution, the 330K plus H1300 solution, specifically designed for large-scale ground mount projects. So the agenda for today involves me introducing the 330K solution, where I will cover some of its diverse applications as well as the key benefits. And following that, Kleber will be exploring some of the technical specifications and providing a detailed analysis. And then we'll be wrapping up with some Q&A. Please feel free to leave the Q&A in the Q&A chat here throughout the webinar, and we'll make sure we'll address it at the end. So with that, let me present to you the innovative 330 kilowatt three-phase inverter coupled with the H1300 power optimizer, which forms our next generation, most powerful ground mount solution. This represents a very significant step for us as we enter the expansive large-scale ground mount market. And it's worth noting that the substantial inverter prior to this has been our 120 kilowatt inverter with Synergy technology. So now let's delve into some of the key benefits of this solution. So the 330K employs a single DC input architecture, facilitating centralized inverter installation alongside distributed multiple MPPTs, or what is maximum power point tracking, across the array. So it boasts a 99% efficiency, 200% DC oversizing, and module-level MPPT with an integrated PID rectifier, and the system yields up to 6% more energy revenue than conventional string solutions. Through fewer, longer strings, we accommodate up to 80 modules per string, and because we adopt what we call the virtual central topology, we are able to offer up to 50% savings in balance of the system, in contrast, again, to the conventional string inverter solutions. And because of the centralized inverter design and the granular monitoring data that it comes with, the system offers up to 100% plant visibility, which means reduced truck rolls and increased system uptime. And not to forget that it does come with the innovative pre-commissioning feature that streamlines all the component validation prior to AC commissioning, effectively reducing any potential delays that could happen in achieving the commercial operation date. And lastly, because we are definitely the safety leader, I would say that the solution comes with the standard built-in safe DC technology that brings the voltage down to safe levels in the event of an emergency or a grid shutdown. So just touching on some of the applications of this solution, it is specifically tailored for community solar, but of course it is adaptable to be used in small-scale utility, agricultural PV, and carport installations. And this solution optimizes performance across diverse energy profiles, business goals, regulations, and technical requirements within each of these segments. I want to talk a little bit more about community solar because this is especially designed to tackle some of the unique challenges of community solar projects. For example, in community solar, a key challenge is locating suitable sites with regular terrain and minimal shading from nearby trees and vegetation. Another obstacle involves acquiring equipment that's optimized for large-scale installations, given that these projects cover extensive areas with thousands of panels distributed across the field, underscoring the importance of panel optimization in a dispersed field setup. And lastly, long-term reliability and operations and maintenance is very important for a community solar project's success. So this is where SolarEdge comes in with our specialized solution for irregular and undulating terrain in community solar projects, thanks to our DC optimization technology. So the approach, as I mentioned before, involves installing inverters in a central location through the consolidation of DC combiner boxes and strategically placing the maximum power point trackers throughout the array distributed across the field using the H1300 power optimizers. And this unique setup is tailored for large-scale installs, and it maximizes both performance and efficiency. The system's main advantage lies in the multiple MPPTs that are efficiently capturing the highest energy yield, even under diverse conditions and landscapes. SolarEdge's granular and real-time module-level monitoring offers operators a detailed overview of the system performance, enabling quick identification and resolution of potential issues. So what this does, it leads to minimized maintenance cost and enhanced system uptime. Kleber will be providing a detailed analysis in just a few minutes to illustrate a community solar project scenario. But before we jump to the next segment, I would love to play a quick video that summarizes the features and benefits that I just explained and the unique value proposition that this provides. So quick video here. All right, so coming back to the slides here, what you see on this slide is the new and complete ground mount solution that features the 330K and H1300, along with the new SolarEdge One manager, which is essentially just the new and enhanced monitoring portal for an even better user experience and more granular data. The SolarEdge One manager that I mentioned that is coming soon is going to be an integral part of the 330K solution. which introduces an advanced monitoring portal with the digital twin 3D site layout view and multi-color coded detection that you see on the screen here, some screenshots of the new monitoring portal. This is specifically tailored for large-scale sites, and it does allow quick identification of underperforming modules and facilitates real-time remote site inspections. So with the remote configuration and operation capabilities, the portal is designed to streamline site operation. It minimizes downtime and reduces the need for on-site visits. Furthermore, it does contribute to a more efficient operational process by reducing the need and the necessity for the IV curve tracing and drone flyovers. So the SolarEdge One Manager, in a nutshell, stands as one of the key components of the comprehensive 330K solution, enhancing monitoring, providing granular data, and also improving the operational efficiency for solar installations. Okay, so I did want to give you a quick glimpse of our new 330K solution in Wairika, California. SunRenew, who is the developer and EPC for this installation, is a loyal SolarEdge customer who uses our rooftop technology, and he strategically they strategically chose the 330K for this 1 megawatt project, integrating two 330 kilowatt inverters and 860 H1300 power optimizers, specifically to tackle voltage drop and power degradation. Having achieved success on rooftops with us and eagerly anticipating this large-scale product, SunRenew discovered that its higher power output not only addressed the specific challenges, but also reduced labor and balance of system costs with the fewer inverters. SunRenew's trust in our optimized architecture fueled their transition from rooftop to ground mount projects. And if you currently use our rooftop technology, you'll undoubtedly find transitioning your ground mount portfolio to this product to be a rewarding experience. With that, let me hand it to Clever, who will explore a thorough analysis to demonstrate how we achieve increased energy generation, reduced balance of system costs, and improved O&M efficiency. Over to you, Clever.
Thank you. Yes, thank you, Varsha. Thank you, everyone. Thanks, everyone, for the attendance. I appreciate them. You're all excited here about the launch of this product, the 330kW. And I know I was monitoring, on the Q&A, there are some questions about the balance of system benefits, that Varsha talked about the energy production. And that's what we're going to be spending a lot of time here. And I don't want to say a lot of time, but majority of my presentation, we'll talk about some details on the product, 3 slides, and then the other slides are really about the benefits, on the balance of system and also on the energy production. Okay, so and again, this is just a snapshot. We'll be glad, if you have a question, if you have questions, or if you need for us to run a project comparison on your projects, like we usually do, like on the rooftop, on ground mounts, we'll be happy to do so, and we can go over and explain every single our logic behind all that. Okay, so I know this slide is a little bit busy, but and the data sheet is also available. It's something it's one of the resources that you have available. Well, let's go through the main specs, right? For the 330kW and also for the H1300 optimizer. Okay. On the inverter side, so 330kW up to 113 Fahrenheit, which is 45 Celsius, and there is no derating up to this temperature level. The inverter actually can operate up to 60 Celsius, but after between 45 Celsius and 60 Celsius, there is a derating. 690 volts AC output voltage, improving inverter power density and reducing AC power losses. DC to AC ratio of possible 200% for energy harvest improvement, and 1500 volt DC design supporting ground mount and carport applications. Okay. Now on the optimizer side, So each optimizer is connected to 2 solar modules, each with maximum power 650 watts. So that's the 1300. So you can put up to modules up to 650 watts. This optimizer supports panels up to, with a short circuit current up to 15 amps. And here is where I wanted to make sure that everyone understands the source of the balance of system benefits. With SolarEdge architecture, DC optimizers are placed in series instead of modules, okay? So DC optimizers control the DC bus voltage to the inverter. Therefore, this allows two key characteristics. Strings up to 80 modules with a maximum string power of 33 kW, and the strings can be of different lengths within the range of 44 and 80 modules. So I say it again, the system allows string lengths between 44 and 80 modules, and when compared to conventional string inverters, which allow a fixed string length, the system yields fewer strings due to the higher amount of panels per string. Okay. So other characteristics, that I believe that are noteworthy, to talk about on this solution. So VAR support. This inverter can push all the 330 kW in form of 330 kVAR, so can go all the way to power factor 0 if need to be, and for grid support. And as Varsha said, right, this inverter, because the system, because of optimizers, it does include the DC optimizers. And upon any fault, upon any issues, the DC optimizers will lower voltage levels at the string level to touch safe levels within minutes. Now, question, does it have rapid shutdown? No, it does not have rapid shutdown. However, it has a shutdown piece. It brings down the voltage for each optimizer, the output of each optimizer to 1 volt within 3 to 5 minutes, okay? The AC and DC terminal blocks include temperature sensors indicating if connections become loose or need checking. PID mitigation system is included as a standard for this inverter, and pre-commissioning of the system is possible as long as the DC array is connected, okay? We heard we have this in the Synergy platform. We heard that was bringing benefits to the customers. We kept in this platform to allow the inverter system to be commissioned prior to AC being available, speeding up plant connection. So having talked about the product specification in its details, I'd like to explore the system benefits that the SC330K DC optimized solution brings. First, I'll show you a high-level plant design so that you understand the design difference on systems between conventional string inverters and the solution we're presenting today, which is the SolarEdge SC330K. Okay. So in the string inverter category, right, we have seen two leading topologies. One that has multiple MPPT inputs, which provides 12 to 16 MPPT. Again, MPPT stands for maximum power point tracking for inverter. And another that has single DC input allowing for a combined DC bus, but has a single MPPT. Both have pros and cons, so let's quickly run through these two examples, okay? First, I'm showing here the multi-MPPT string inverters, okay? In this configuration, the inverters are distributed throughout the array. While this reduces DC balance of system costs, it increases AC BOS costs and AC losses due to the long AC wire runs. Additionally, as the DC to AC ratio increases, this configuration will experience greater losses as it cannot take advantage of the free voltage drop that is possible during times of clipping. Another disadvantage is the higher cost of communication circuits to the inverters because the inverters are spread across the array. Okay? The advantage of this configuration is that it allows for increased energy harvest due to the number of peak MPPT per inverter. Okay? So that's the multi-MPPT string inverter flavor. And so let's look at the next one. The other solution in the market has inverters, or like string inverters, with a single DC input. In this case, the string inverter has a single DC input, which allows the use of DC combiner box or wire harnesses with aluminum feeders to reduce DC cabling costs. However, since these inverters only have only one MPPT, the energy harvest is lower when compared to the multi-MPPT inverter solution. Okay? So while electrical costs, electrical balance of system costs can be reduced, energy production is also lower. Okay? Each of the previous solutions had its pros and cons, right? And you can either optimize electrical balance of system or energy production, but not both. This slide that I'm showing here brings the configuration for the ST330K DC optimized solution. This solution allows installers and owners to enjoy the best of both worlds. That's what we call the best of both worlds. Optimized EBOS, electric balance of system, and superior energy harvest. It combines the benefits of virtual central inverter configuration, which are low AC costs and losses, and easier O&M, with the benefits of string inverters, modularity, and plant availability. At the same time, DC cabling costs are kept low by using DC combiner box or trunk bus solutions and aluminum feeders. Superior energy production is achieved with DC optimization, which performs module level MPPT. And this is why we call this a unique architecture. That's why Varsha mentioned that that's a unique architecture, because it combines the best of both worlds. The use of this optimization allows for even lower strings when compared to conventional 1500 volt DC string inverters, as well as the flexibility to use strings of different lengths. It is worth saying it again, the solution enables up to 80 modules connected per string, and energy is harvested at the module level. Longer strings of modules translate into fewer strings per inverter, which means fewer disconnects, fuses, and overall savings on DC cable. Okay? So now let's start kind of giving you some numbers, and that's kind of what I mentioned to you. So this analysis that we do, we do this project comparison for all of our new customers, and we provide, the math behind this, and our methodology has been approved by independent engineering groups, by a couple of engineering groups. And I'm going to show the next two slides, the balance of system comparison, energy comparison. Okay? So in order to compare the three configurations for balance of system, cost and energy production, we ran the balance of system models using the topology of a community solar project in the Northeast US. This project was chosen as it is typical of many community solar projects with irregular shaped fields and sloped terrains with obstacles that cause shading. This is about 8 megawatt DC project. The numbers were achieved using commonly used tools in the industry, such as Heliorscope. The ST330K DC optimized solution provides the lower balance of system costs, as you can see here, for both for AC and DC circuits. The reasons for this advantage are the use of DC optimization, which reduces the number of string count and therefore DC balance of system. The virtual central configuration reducing AC balance of system, and the size of the inverter, which is 330 kW, which reduces the number of inverters per plant. As you can see, the savings are between 30% to 46% between the two string inverter solutions and the ST330K system. Okay, so that's what I'm showing here: AC balance of system in blue, DC balance of system in gray, and then the number on the top, that's the savings in percentage between the other solutions and our solution. Okay. We also ran a energy calculation for the three models using the same site previously, and we use PV systems that we use, and this is also something that we always do. We show to our customers something that you have access. We send you so that you can check on the numbers. The ST330K DC optimized system provides significantly better energy production when compared to both the string inverter solutions. Okay, so here's what I'm showing the first two columns, right? And it's megawatt a year 1, year 20, and then the revenue over 20 years using NPV, using like a discount rate of 6%, 12 cents per kilowatt hour, typical for a community solar. And on the right-hand side, that's the SolarEdge inverter. I mean, that's megawatt hour production, the revenue, and then the advantage in terms of NPV, that for the comparison of the difference from the multi-MPPT to the 330K is about $1 million for the whole plant, the whole life plant, right? And 1.1 million, about 6% improvement when compared to the single MPPT. Again, why there is a difference, right? I mean, between year 1 to 20, because this optimization is doing a module level MPPT and is taking better care of panel degradation. Okay, so we're not susceptible to panel degradation, panel mismatches. Okay. Another key advantage when using DC optimization is that monitoring is performed continuously at the module level. So voltage, current, energy production levels are provided for each DC optimizer which are connected to every two modules. This solution creates the possibility to have full visibility for plant issues, including the DC side of the plant. I presented a webinar with NovaSource in 2022, middle of 2022, and a data set shared by them is that greater than 90% of the issues happen on the DC side of the plant, and these are typically detected only via an aerial inspection, which happens once or twice a year. Module level monitoring enables continuous and granular data, which allows for issues to be caught early and provides the asset manager the tools to determine whether and when a crew needs to be dispatched. Over the life of the project, we estimate savings of about $50,000 per megawatt DC on O&M expenses with the full visibility of plant issues. These savings come from lower number of IR inspections and fewer truck rolls. And also, you don't need to do IV curve tracing, right? I mean, so those are the main benefits of having full visibility and continuous and granular data with the DC optimization. So now I would like to run through a poll here. So from a perspective of ground mount applications, community solar, small utility that use string inverters, right? What is the greatest challenge, for ground mount applications that you see? So go ahead and start answering. So commissioning delays, equipment installation and related logistics, equipment operation and maintenance, and others. I say others here. Please go ahead and put an answer in the Q&A. I would love, me to catch up with you folks. Me to have any other ideas or any other challenges, that you'd like to have, that you'd like to pass on. So give a couple of minutes here. We've seen, several folks, several customers, telling us, saying that, those are the main challenges, right? Commissioning delays, equipment installation, related logistics. I know that, especially after COVID, there has been few issues, right? With lead time, but now things are starting to get better. So I'll give 10 more seconds here, then we can go ahead and move on. Right. Okay, so let's see here. So looks like equipment installation and related logistics. Yes, I see a lot of those, and especially if the equipment is not pre-installed or not pre-wired, customers have a lot of issues. Commissioning delays as well, especially if the equipment, that you have delays to turn on when you have like AC connection. So that agrees, with what I had in mind as well. So thanks for that. So let's move on. We have 5 more slides here, and now let's talk about tracker applications. So trackers have become common in solar projects due to their ability to increase energy production throughout the day. However, optimizing the use of trackers are usually a challenge. Trackers are cost optimized to a certain row length. This means that in projects with irregular shapes or length constraints, or when conventional string inverters, or when using conventional string inverters because of that they don't have flexibility on the string length, it is rare for the full length of the trackers to be used and unlock the full advantage of the tracker. As mentioned previously, the DC optimized solution provides greater flexibility by allowing longer strings and the strings of different lengths to be used. Let's look at how this works. Okay. So I'm going to go through two examples here. So this I'm showing here tracker tables, right? For a given tracker optimized, first let's look at tracker optimized for 96 modules per tracker table. I'm showing here how the tracker is populated when using the SolarEdge DC optimized solution and conventional string inverters. Because our system allows for longer strings and of different lengths, anywhere between 44 and 80 modules, this tracker is fully populated with 2 strings of 48 panels each. That's what you see on the top. On the other hand, when using conventional string inverter that allows for a fixed number of panels per string, like string inverters typically 26, 28 modules that we usually see, one can only fit 3 strings of 28 panels each, resulting in 84 modules per tracker table. This means that the tracker table is not fully utilized, leaving about 12 module positions empty. Okay? As a second example, there's also another very popular tracker table there. The tracker table can fit 120 modules. Using SolarEdge system and its flexibility, the tracker table can be fully used with 3 strings of 60 modules each. But for a conventional string inverter with 20 modules per string, one will be able to fit 4 strings of 20 modules each, leaving an empty space of 8 modules. Okay? So now we'll look at a few examples on how this flexibility yields benefits on balance of system and energy production. Okay? To understand the full set of benefits of DC optimization in tracker applications, okay, we picked a typical community solar site in the Northeast. We designed 4.8 megawatts DC using typical 540-watt panels and ran the study for both SolarEdge SC330K and conventional string inverters. A tracker optimized for 96 modules per tracker table was used, and for the previous slides, right, the SC330K system used 3 strings of 48 modules, and the system with conventional string inverters used 3 strings of 28 modules, resulting in an empty space of 12 module positions per tracker table. So let's look at now. The comparison here, we assume that the developer wants to keep the same kilowatt DC, right, for both SolarEdge and conventional string inverter. As the conventional string inverter only allows for 84 panels per tracker table, which is 28 modules times 3 strings, this system will need 105 tracker tables to fit the solar panels needed for 4.8 megawatts DC. On the other hand, the SC330K inverter system, with its flexible string design, can utilize on the other hand, right? I mean, the table, they can utilize the full extension of the tracker, so 48 with the 96 module. Okay. So as you can notice, there are 13 extra tracker tables needed on the conventional string inverter case. And in this case, we're assuming that the developer has access to more land to accommodate additional 13 tracker tables. So in this case, the SolarEdge system has the advantage of using 13 fewer tracker tables, plus the added energy production of about 3% year 1 and 6.5 year 20, due to module 11 PPT when compared to conventional string inverters. So energy revenue gains is about $526,000 over the project life. Okay. Now, however, I mean, when we showed this, to a customer, they said, Kleber, look, land is not always available for us to put extra tables. So because land is not always available for tracker tables, right, we ran the case when more land is not available for the additional tracker tables within a conventional string inverter system for a set kilowatt. Again, the system with conventional string inverters need to use 13 more tracker tables than the case with a system with the SC330K. And to fit these additional 13 tracker cables in the same plot of land, the designer needs to increase the ground coverage ratio, DCR, which shortens intra-row spacing, potentially creating inter-row shading. Okay? So you need to make the inter-row spacing shorter, right? So that you're not, so that you can fit all of the panels. Okay. And the bottom line is that the SC330K advantage remains that it needs 13 fewer tracker cables than the system with conventional string inverters and increased energy production. The energy revenue increase in this case is about $870,000, so it's an NPV over 20 years, which includes an additional $344,000 when compared to the previous scenario. Why is this? This extra 344K in energy revenue is due to the higher DCR for the system with conventional string inverters, which in turn forces the trackers to start backtracking earlier to avoid inter-row shading. So you make the inter-row spacing shorter, right? And then to avoid shading, the angle of the trackers, are not as high as the SolarEdge system. So they have to start backtracking earlier, and that's why we are able to get more energy in the morning and also the late afternoon. As a last use case here, we ran a comparison for one of our customers using a tracker system optimized to 100 modules per tracker cable. In this case, the conventional string inverter used strings of 24 modules. As you can see here, the SolarEdge system used the tracker cable fully with 3 strings of 50 modules each. But on the other hand, the system with conventional string inverter can place 4 strings of 24 modules each, resulting in 96 modules total per tracker cable, and therefore leaving an empty space of 4 module positions. That's what I'm showing here on this slide. So what this means, by allowing the developer to fully use the tracker cable, the developer can place 4 more modules per tracker cable, and the net effect of this is that there are 500 more modules in the plant for the SC330K system, which totals, right, 305 kilowatts DC more DC power, using the same number of tracker cables and same DCR. Okay. The benefit here is extra energy production. Again, we're using the same tracker cables, we're using the same DCR. However, because we can fit more panels per tracker cables, we can fully optimize, we can put 500 more modules on the whole plant, which results in 305 kilowatts DC. What this means? This means that there's a total of $1.4 million in increased energy revenue gains with SolarEdge system due to module level PPP, but $600,000 of this total is due to the additional 305 kilowatts DC from the 500 extra panels by fully using the tracker cables due to the flexibility allowed by the DC optimized system. Okay, so this is no small gain. Okay. All right, approaching here the end. I also want to talk about virtual central solutions. Okay? As a last item for the presentation, we have partnered with EPAC, the folks in North Carolina. They're located in North Carolina, Raleigh, North Carolina, to offer virtual central solutions that can be completely wired in the factory with minimal work in the field. This is especially important if you must pay for prevailing range. We have created 2 standard designs, a 1 megawatt and a 2.5 megawatts. While other sizes are allowed, these standard designs sizes will have shorter lead time due to shorter engineering cycles. So the first design is a 1 megawatt AC, and the design includes an inverter rack with 3 inverters, AC breaker panel, and other auxiliary components. So very simple, it can be wired in the factory and sent to the field so that you can just make the connection between the transformer and the AC breaker panel. Second design is a 2.5 megawatt AC. The design includes an inverter rack with 8 inverters, a junction box between the inverters and the AC switchboard, plus auxiliary components. That junction box is there so that everything is wired to the junction box from the inverter on the AC side, and then from the junction box in the field, you can wire to the switchboard. The AC switchboard with inverter breakers and optional optional main breaker can be mounted on a platform on a pad, close coupled with the transformer. And information on virtual center designs will be available during the sales process, and our sales and application engineering team will be happy to support you to tailor this solution to your project. Cool. So, in a nutshell, so what are the main advantages? Unique architecture that optimized for the centralized solution, so with single DC input and multiple MPPTs, up to 6% more energy revenue gains, up to 50% savings in electrical balance of system, and lower cost for O&M with continuous and granular data and full visibility to system issues. Okay, and safety, as we talked, safe DC, bringing the voltage to touch safe levels in case of a fault. And UL 1741, yes, the inverter does have UL 1741, and this is something that we want to, last but not least, to show that we do have 1741 SD supplement fee certification, and we are good to go if you need that, if you need to supply that to interconnection process, we have that available. And resources, it's going to be available. We have available online a data sheet, installation guide, quick install guide. We have a catalog, and Barsha we will be able later on if you need anything, we can point you in the right direction. Thank you. With that, I'll pass that back to Kelly.
Okay. Now we're going to get into the Q&A portion of the webinar. I see there are a lot of good questions in here, but please continue to submit your questions and we will make sure that we get to them. So I'll let you guys take it from here.
Thank you, Kelly. Yes, there's a ton of questions coming here. Just in case we do not get to your question today, please note that one of Clever's team or somebody from Clever's team should be able to send a response back to you. So rest assured you'll get a response. All right, let me start going through some of these questions here. Okay, so Clever, a question here. A great question is, can the 330 kilowatt inverter be used in rooftop applications where rapid shutdown is required?
It's no. So that's a very good question. The inverter cannot be used in rooftop applications because it does not include rapid shutdown. Like I mentioned, it includes the shutdown. It brings voltage, right? I mean, within touch safe levels, within minutes, but not within 30 seconds. However, this is a good product for carports. So if your carport application allows for a 1500 volts DC and there's no rapid shutdown requirement, then this product can be used for carports.
Thanks, Clever. I think Larry here asked a question before you presented the 6% production increase. Larry, we will ensure that we send you the deck along with the analysis after the
Yes.
after this webinar here, so you'll get access to that. Let's see. Will this inverter be able to integrate with a battery container system?
So at this point, if it's AC coupled, I would say in the battery, the battery system, the battery container has a PCS, then likely yes. So then it's a matter of controls, but we are not at this point allowing this inverter, this PCS, to be connected to a battery system on the DC side at this point.
Mm-hmm. Okay. Charles has a question here. Is AC output at 480 volts possible with this solution?
It is not. No. At this point, we have that's 690 volts AC. That's the only option.
And James is asking, can we still use the old SolarEdge monitoring site if the owner already has a number of non-330 kilowatt inverters being monitored? And the answer is yes. Yes, you can still use the existing monitoring platform. Yeah. Thanks, Clever.
That's right.
And let's see, is this product suitable for the Canadian market?
Yes, it is. although not necessarily for rooftop, but for ground mounts, yes, it is perfect for. I mean, it's okay for the Canadian market.
Okay, and also for carports, Clever?
And for carports, yeah, as long as it allows 1500 volts DC, as well as it doesn't require rapid shutdown.
Sounds good. Let's see here. There is a question about, can you elaborate more on pre-commissioning? I can answer that one. So yes, pre-commissioning is essentially you're performing the DC commissioning on the inverters prior to completing the AC connection to the electrical grid. So it's DC commissioning that's performed in daylight using the SolarEdge setup mobile application. We also call it commissioning from the sun. Hope that helps. Let's keep going here. Will SolarEdge be releasing a DC combiner panel with the 330K?
No, because the reason being is that, I mean, for DC, we're not releasing that because this is just a regular DC combiner box. You know, there is no need, you know, nothing special that is needed. So then there is no, we're not releasing a DC combiner box with this solution.
Let's see. Is there a requirement for the AC recombined to be SolarEdge OEM for warranty support?
The AC, no, it's not. So that's a very good point. The virtual central solutions that I showed to you, that's something, you know, that we heard some customers and we listened to our customers that was a need, you know, especially with switchgear availability. So therefore, we created that. However, there is no requirement to use that solution. You can buy the inverter. You can do the pre-wiring, right? I mean, in your factory, and you can get any switchboard or any connection. There are requirements, though, with regards that you need to have a fuse or a breaker for every single inverter, but we can get into the details during the design phase.
Excellent. Thanks, Clever. There's another question. Would the commercial inverters work with Tesla solar roof?
Can you repeat the question, Varsha?
Yeah. Would these inverters work with the Tesla solar roof?
No, it will not. No, it does not. Yeah, because this is mainly really for, I don't know if this is the Tesla battery that they mean, but for the rooftop, no, it does not. However, if it's like the Tesla, the mega pack, you know, like I explained before, if it's AC coupled, then yes, there is a possibility to work on the AC side, AC coupled.
Sounds good. And can I place orders for the 330K now? When is it available?
Yes, it is available. It's available to order. We have orders already that for customers that are waiting for the inverters and optimizers. So it is ready to order. Just contact our sales folks and we'll be happy to point you in the right direction.
There's a question from Christopher. Will the system operate with high efficiency bifacial modules, such as BYD-520 watt panels?
I believe so. I need to make sure that we understand. I mean, we get the two things that needs to pay attention to is that from bifaciality perspective, there is no problem. There is no issue with the optimizer. However, we need to check on. So it's 500 watts should be fine. The next thing to check is the short circuit current without bifaciality. So if without bifaciality, we're looking at the G12 modules, that's like 18 amps, you know, so then this H1300 will not be compatible. We're working on an optimizer for later on this year, but for now, this is the optimizer that we have.
Mm-hmm. I see a lot of questions here about just the specifications and the data sheet. I just wanted to note that in case you do not see it as a resource available here, we will be sending it to you via email in the next week, along with the data sheet and some of the other technical product documentation So please stay tuned for those. Which data logger can be used with this?
So any data logger, we have our own data logger, as Varsha mentioned, but third-party data loggers, as long as it talks Modbus, RS-485, it should be just fine. Can be similar to what we're doing with the other Synergy inverters. It remains the same.
Mm-hmm. Sounds good. James is just trying to figure out if he can get help designing a 400 or 500 kilowatt system that he has using the inverter. So Clever, I'm assuming we can have that sent to one of your team members to help him with that.
That's correct. Yes.
Okay.
Send us a note, and we'll help you with the design. It's also this inverter is also available on Designer, which is a SolarEdge tool. So we can either do via there, or we can help you with that. Absolutely.
Yes, and anybody who sent a note to us here will definitely receive a response. But if you don't, please feel free to email us at training@solaredge.com, and we'll ensure we put somebody in touch with you in case you do not get an answer here. Let's see. What support can SolarEdge provide to ensure IV curve testing is excluded from initial contract negotiations?
So IV curve, right? So I think this is also something that we need to go on the details. We can present to you with the monitor platform. There is a white paper, an article that talks about the benefits and how we do collect voltage and current, how we do voltage mismatch, how we do power mismatch. So this is something we can provide you with all of the material. And we can also, our applications engineers, we can also help you with discussions, with during the contract. However, we do not get, we're not going to get involved in the contract negotiations, but we can support you with all the technical side.
And Clever, remind me again, is this platform on the Designer? On our Designer too? There are a couple of other questions just asking that. Okay.
Yes, it is.
Great. Let's see here. There's plenty of questions coming. Thank you for those. Keep them coming. Can you explain the voltage requirement for this inverter? I think James just wants an explanation on why this is being used versus the 480 volts AC.
Good question. So the 690 volts AC. So this is a trend that we're seeing in the industry, right? For large string inverters for ground mount applications, especially behind the meter, front of the meter, to have a higher AC voltage than 480 volts AC. Okay. So some inverters, right, have gone to 800 volts AC. And we are at 690 volts AC because that was, when the inverter was specified, there had like several wind turbines, right? That are connected to 690 volts AC, and also we picked that voltage level because of equipment availability. Okay, and the reason that we are going up in voltage, that we went up in voltage, is to be able to improve the power density of the equipment. So power electronics, it's always rated in current. So there's a maximum current that you are able to push through the IGBTs, through the inverters. And with the higher voltage, then you're able to get more power. So more power, more AC power, lower cents per watt. And that's why you see a lot of the balance of system advantage there is that, when you pick like a 250 kW inverter or a 200 or a 150 kW solution, we use fewer inverters and therefore less balance of system.
Yeah, absolutely. That's how we get the balance of system savings. Clever, there's a very good question here on the training. So will there be specialized training available for technicians that are wanting to learn how to service this inverter in the future?
Yes, it is. As we just released this product right now, we are going to be our team is currently working on the training material, and I expect it to be available training, around late Q1, early Q2.
Excellent. Let's see. What is the DC operating current per string? And I know, Kleber, you did touch on this.
Yeah, the DC operating current is 20 amps. So it's 20 amps per on the string current.
Mm-hmm. And there is a question about, does this able to handle different string lengths?
Yes. So like as I mentioned, right? So because we are the optimizers, you are series, you're putting a series of optimizers and not panels. We are seeing, theory, it's 44 modules, minimum 44 modules, all the way to 80 modules. Realistically speaking, what we have seen is that we're designing up to 60 modules per string. So that's where we're seeing like between 44 and 60 modules. And therefore, that's why I went over the benefits on the trackers, is that you are able to design a plant with 55 modules or like 48 modules per string, or 52, or like even 60, right, or 50. And this is it provides balance of system improvement as well as on the trackers.
Yeah, thanks, Kleber. And I think it can, of course, take modules up to 80 modules per string. And what Kleber just referred to is the design flexibility, right? You can use any number of different number of string lengths.
Correct.
There is just a question on the training. Are you providing both in-person training and Edge Academy? And I think the answer is yes, Kleber, right? We're going to be doing both at some point.
Correct.
In the near future. Okay. There is, I think, somebody from Brazil here. Hi. Do you think the 690 volts would work in Brazil?
690 volts. Again, it's like if a connection, if it's behind the meter, right? You want to avoid any transformer, and you are like in a building, probably not. And we're seeing, this inverter, it's the sweet spot for this inverter is in a plant where you have your C collection, you transform to medium voltage right there, right? There is no building connection. However, there is always the exceptions to the rule, right? As mentioned, as Varsha mentioned, our launch project, it is in a commercial establishment connected at 480 volts AC. So the customer decided to use that. Actually, because it is a ground mount behind the meter, you have the building, it's a hotel, a building, and the array is very far from the connection. So they like the 690 volts AC to deal with AC losses, with the long AC run. So they transmit 690 all the way to near the building, and then they step down from 690 to 480 volts, and then they feed the building. We have seen some like installations. The Northeast, there is another installation customer using. It's a 3 megawatt carport application, where it's a large commercial application where they have their own substation. So they're connecting everything at 690, and then stepping that up to medium voltage level.
Thanks, Kleber, for that detailed answer. One last question is, how many MPPTs does this have? And I think Kleber and I both spoke about multiple MPPTs and module level. And it's module level.
That's correct. Yeah. It's for you to understand is pick the number of modules, divide by 2. That's your number that you have per MPPT. Right. I do want to answer one question that came out to me. That balance of system includes equipment, like inverters and optimizers. No, it does not include inverters and optimizers. There's always, kind of price variances. So this is just a balance of system, electrical, and installation. Okay, so electro wires, conduits, and true balance of system comparison.
That sounds great. Yeah, we definitely have a few more questions to answer. So we will, just to emphasize, we will send you an email with all of the resources, specifically the technical documentation with the data sheet, and the quick install guide and the installation manuals. But we will also have somebody from SolarEdge, either the sales manager or somebody from Clever's team, an applications engineer, reach out to you and provide responses. So please stay tuned. Thank you so much for your patience, and yeah, appreciate your business. Thanks again for your time, everyone. Kelly, back to you.
Thank you. Yes. Thank you, Clever. Thank you, Varsha, for being here. Thanks for SolarEdge for sponsoring today's webinar. Thank you to everyone for joining us today, and really hope to see you at more Solar Power World webinars in the future. Thank you.
Thank you all. Thank you.
Thank you so much. Thanks, Kelly.